Okay, so what we're going to talk about right now is using vertical angles in a proof. So vertical angles, if you remember correctly, anytime you have two lines, line segments, rays, anything crossing each other, where they form an X like this, the angles across from each other are called vertical angles. They're called that because this point in the middle where the angles all meet is the vertex. It's the vertex for all four of these angles. It's a common vertex. So the angles across from each other are called vertical angles. So there's one right there, and there's the other one. This is the vertex. Okay, now the vertical angles, the important thing about them is that they are congruent. So if we have a single arc here, a single arc here, if it's a double arc, that has to be a double arc. They're going to be the same angle, right? If this is 50 degrees, that's 50 degrees. So this is going to be important because whenever we see vertical angles, we should be able to recognize them. Once we learn how to recognize them, then we know that we have congruent angles, and sometimes that's helpful for us. So if you remember, when we're trying to prove angles congruent, we need three pairs. So three side pairs, or two side pairs and an angle pair in between the two sides, or two angle pairs with a side pair between the two angles. Okay? Now, if you don't have those, if you only have two, that's not enough. And that's the problem we have over here. When we look at our given information, remember, is written over here, but it's also here. So this picture, this diagram, is given information as well. So we can use anything we want from the picture, anything that we recognize. So it doesn't matter. Now, the way we've done it, or the way it's been done, is that AC and CD, these sides being congruent, it's been written here, but it's also been marked down here. If it's not marked here for you, then you should redraw it and mark it in yourself. So we have AC, CD, that's one pair of sides, one pair of sides. So what we have is, we have sides so far. Now we go to BC and CF. BC, CF. There's another pair. Okay, no skips, so this is side, side. If we go this way, we're skipping the angle and a side, so we can't go this way. So we have side, side so far, but that's not enough. So we need either that one or this one with an angle in between. So you should be able to recognize vertical angles anywhere there's an X. And don't let the other sides confuse you. Anytime you see crossing lines, you should be thinking vertical angles. Okay, so if we can make our diagram look as complex as we want, but anywhere you look, anywhere you see crossing lines, we have vertical angles. So these two angles are congruent. These two are congruent. Now that doesn't mean they're congruent to these down here, right? I can't use a single arc or even a double arc unless I know that these two are the same up here. So I'd have to use triple arcs. So I don't know these two are congruent, but I know the angles across from each other are congruent. And that's what we're going to focus in on here. We have crossing lines. So the angles across from each other, we know they have to be congruent. Mark them in place. So now, once you've done that, this angle pair and this angle pair, and what do we have? Without skipping, we have side, angle, side. Side. Well, starting from this, since I started on the one, I should start on the one tick mark here too. So it's still side, angle, side. It's going the opposite direction, but it's still side, angle, side. This is the one we're going to be using. Not this one, not this one, side angle side. That's what we do. By taking a few seconds or a minute to look at this, we can plan this out and we know what we're going to do. In general, almost always you're going to start with the given information. So that's what we start off with first. So I'm going to put AC congruent to CD. We know those are congruent. The reason we know they're congruent is it was part of the problem. It was given to us. So that's a pair of sides. Then we have BC congruent to CF. And we know that because it was given to us. Okay, so we have two side pairs. And then lastly, we can't just use one single letter for to represent the angle, because this is a common vertex for all four angles. If we say angle C, we won't know which one of these four angles we're talking about. So we have to be more clear about that by using three letters. This letter C will be the middle of the three for any angle we pick. So it'll be, we'll use the C twice, but it'll be angle ACB or BCA. It doesn't matter which direction you go as long as that's in the middle. So I'm going to go BCA, and that's going to be congruent to, I messed up. Let me rewrite that. So angle BCA, I didn't give myself enough room. It's going to be congruent to, that has to be in the middle. So you don't have to do it in the exact same order, as long as that's being in the middle is what's important. But I went with from B to past the 2, I'm going to go FCD. Again, the important thing is the C is in the middle. So we know BCA is congruent to FCD. The reason we know that is because these are vertical angles. So we know vertical angles are congruent. And you can write it out. I'll write it out. Okay. Now, that's an angle. Side-side angle is not the correct angle triangle theorem. So you're going to get 3 letters, and the main reason for having the 3 letters here is just to make sure you have the right number of pairs. Now, once you do that, then you have to double check to make sure that you have them in the right order. Okay, so we just go back up here. AC is this one right here, and then we get to the angle, which is this one. So we're not actually using this order. We're using the order from the picture. So this is BCA is right here, and then the last one, and we have side angle side. So we have them all marked. We can use those markings, and we can see that we have side angle side. And so now once we have everything, we have the side angle side, now we're going to use our proof statement. The proof statement always goes last. That's the last thing that you put down. So triangle ABC, congruent to triangle DFC. And like I said, that's our proof statement. But how do we know that it's true? Side angle side. Okay. So that's what you get. And let's do one more. I'll try to do this one a little bit faster now, since we've already done one. I won't take quite as much time. This one, I left this completely blank. So the given information is here. Now this is enough to go by, but you really shouldn't try to use only that. You take advantage of the picture. So what I recommend doing is redrawing it on a separate piece of paper and then marking everything in. So we have angle E, that's right here. It makes it easier to see what's happening. Angle E congruent to angle D. AE is this one, congruent to AD. So by doing that, it makes it a little bit easier, I think, to formulate your plan. So we've got, what are our choices? Side, 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 angle, side, angle, side, angle. Now, since we have one angle already and a side, we're probably not going to use that one. We're going to either need to find another side or another angle. Whenever you see these crossing lines, you should be thinking vertical angles. Check it to see where the vertical angles are. And they're right here. Now look and see what you have. Okay, we have a pair of sides that matches up, a pair of angles that match up. I'm sorry, I'm confusing myself. A pair of angles that match up, a pair of sides that match up, and then these are angles. So a pair of angles that match up. So what we have is angle, side, angle. That's the one we're going to use. Angle, side, angle. So all you have to do now is write down the information. So the first thing is angle E congruent to angle D. Given, because it's told, they tell you at the beginning. AE congruent to AD. Given. That's an angle. That's a side. And then the last thing we need, there's nothing more here given, but we figured this out right here. We know that angle DAI is congruent to angle EAT. Okay, so again, A is the shared vertex. That needs to be in the middle. Now, how did we figure that angle out? How did we figure that out? We used vertical angles. So vertical angles are congruent. Sometimes if you just use the vertical angles theorem, that's fine as well. But I like writing it out so that you remember what the theorem actually means and says. So the last one is our proof statement. Triangle ATE is congruent to triangle AID. And how did we get that? ASA. And that's our proof statement. So I hope that helps.